Hi, Professor Stafera here. This is the video on the structure of the atom. Atoms are the smallest part of any element, and understanding their structure ultimately will allow us to understand how they form bonds with each other, and that's going to explain how molecules are formed, and we'll take a look at that in relationship to how living organisms use molecules to maintain life. So let's take a look at the first slide here. This slide describes what a compound is, and a compound consists of two or more elements combined in a fixed ratio. And here we see the two individual elements in this figure. The first one here is sodium. Remember, sodium is sodium chloride, or N lower class A. And then chlorine is the other element that's shown here. Chlorine in this case is a gas in its elemental form. Sodium is a metal in its elemental form, a kind of solid. But when those combine in that fixed ratio, they create something quite different, which is sodium chloride or table salt. Each of those elements individually are poisonous, but sodium chloride is table salt, and we use it quite readily to season our food. This would be the way we would describe sodium chloride forming that compound. So the idea here is that each element has a unique state of matter, but that uniqueness can change when we combine it with other elements. Those compounds then will have unique qualities themselves, unique states of matter. Many compounds that are associated with living organisms are going to contain the big four. Those are carbon, hydrogen, oxygen, and nitrogen. So remember, carbon we symbolize with a C, hydrogen we symbolize with an H, oxygen we symbolize with the O, and then nitrogen with the N. And most of the molecules that we see in living organisms actually have a combination of all four of these. DNA is a good example of that. It will have carbon, hydrogen, oxygen, and nitrogen as a part of forming its structure. And when those combine, they form deoxyribonucleic acid, which is the molecule associated with inheritance, associated in the cell, and it is the molecule of inheritance. The arrangement of elements into compounds, as I said, is going to be associated with their state of matter and the transformation of that state of matter as they combine to form these different compounds. So an atom, again, is the smallest unit of matter that still retains the property of any element that we talk about. And atoms structurally are made of what are called subatomic particles. And there are a variety of those, but we talk about three main particles. And those are the protons, the neutrons, and the electrons. Protons are a subatomic particle with a positive charge. Neutrons are a particle that do not have a charge, so they're defined as being neutral. And electrons have a negative charge. So let's see how those three particles distribute into the structure of an atom. And we'll use helium here as our example. So helium, our atomic symbol is He. And here we can see how the protons, neutrons, and electrons are distributing into the helium atomic structure. So the protons and the neutrons will take first. They're located in a dense area of the atom called the nucleus. So the nucleus is this dense area, and I'll just sort of dot around it within our atomic structure. We have two models here showing the position of these particles, and so I'll just dot around them. So the purple or pink are the protons and the black are the neutrons, and they form the nucleus of atoms. And in this case, because we're talking about an atom of helium, we're going to see two protons and two neutrons. The electrons are the particles, subatomic particles, that are found in this electron cloud that distributes around the nucleus. It's a volume of space where the electrons reside. And the negativity of the electrons is attracted to the positive charge of the protons, and that's what holds those particles together, holds the electrons close to the nucleus in this case. Notice here they're describing a value associated with an atom, and that's called the mass number. The mass number for helium is 4 because it's the combination of the number of protons in the nucleus, and I'll use P to symbolize that, plus the number of neutrons, and I'll use N here to symbolize neutrons, and that leads us to our mass number. So elements are going to differ in the number of protons, neutrons, and electrons. We just saw helium with its 2 protons, 2 neutrons, and 2 electrons, and any atom that is structured that way is called helium. Now, a different element is going to have atoms with a different structure. So carbon is going to have atoms with 6 protons, 6 neutrons, and 6 electrons. And so that's what really characterizes these elements as being different from each other, is how many subatomic particles are associated with the atoms of that element. So the neutrons and the protons are packed into the nucleus. That's kind of the core of the atom, this dense area where those subatomic particles are found. And remember, we called the mass number the total number of particles in that nucleus. It's going to be the number of protons plus the number of neutrons. Another value that's associated with the structure of an atom is the atomic number. And the atomic number is the number of protons only. And so for helium, we had 2 protons in the nucleus, so its atomic number is 2. Carbon's atomic number would be 6. And again, we've talked about the mass number. The mass number for carbon is going to be 12 because it has 6 protons and 6 neutrons in its nucleus. Here's our carbon atom displayed in this particular model, and we can see the nucleus with the protons and the neutrons, and so 6 of each gives us our mass number. And the atomic number then will be the protons. And it's interesting, in a neutral atom, a neutrally charged atom, which is what we have here, right, the number of protons with their positive charge is equal to the number of electrons with their negative charge. So when we are talking about an atom that is electrically neutral, and we describe its atomic number as being 6 in this case for carbon because it has 6 protons, that automatically tells us something about the number of electrons. It tells us that if there's 6 protons, then there's going to be 6 electrons. The other thing that you see here on the slide is this unit here that's being identified, and that's the atomic mass unit. And the atomic mass unit, in this case for carbon, it's 12 atomic mass units, and it's a very tiny number. You can't see it there because of the Dusseri tag, but it's 1.67 times 10 to the negative 24 grams is the unit value of 1 atomic mass unit. So it's a tiny piece of matter. And then even tinier are our electrons, which are 1/2000th of an atomic mass unit. So it gives us some scale to think about the size of these atoms in our individual elements. Electrons, we'll talk more about electrons in the next video, but again they travel around this electron cloud. And again, that's the volume of space around the nucleus. And so they'll be moving around in this volume of space. And they are placed in this volume of space. It's referred to as energy shells. So that's what we're going to talk about in the next video, is the electron distributing themselves in the electron cloud in what are called energy shells. This last slide is what you're going to use to summarize your understanding of the structure of the atom. So please download the video summary of the atom and complete this table, as well as a couple of other questions that are on there, and they're going to be related to the video you're going to see next, which is our two dogs teaching us chemistry. I hope you enjoy the video, and I'll see you in the lecture.
Welcome to Dogs Teaching Chemistry. Our second lesson is on the atom. All substances are made up of matter, and the fundamental unit of matter is the atom. Atoms are made of three smaller things: protons, neutrons, and electrons. Paige and Dexter are going to help build an atom. Protons are positively charged particles. Neutrons have no charge and are neutral. Protons and neutrons are located in the center, or nucleus, of the atom. Electrons move around the outside of the nucleus and are negatively charged. Electrons move about so fast that they form clouds that surround the nucleus of the atom. Let's try to figure out what element Paige and Dexter have made. Dexter is counting how many protons we have. That'll give us our atomic number. Looking at the periodic table, you can find the atomic number, which is usually located in the upper left corner of an element square. The atomic weight is the number located on the bottom, which is the number of protons and neutrons in an atom. Great job, guys! The element is helium. Thanks for watching, and we'll see you next time.